This video is made for 12th standard. The topic is differentiability. See, we start with this graph. There are two types of curves. One is smooth curve, another one is sharp edged curve. Correct? There are some sharp edges. It is not smoothly drawn. Okay. So to identify the types of curves, we are going to use this differentiability. Okay. If the curve is smooth, actually we can say differentiable curve. If the curve is not differentiable, not smooth means maybe we can call some sharp edged curve or discontinuous curve, or called a non-differentiable curves. Okay, if you know graph, by seeing itself you can decide whether it is differentiable or non-differentiable. Differentiable curve means it should be continuous and smooth. Non-differentiable curve na either not continuous or smooth sharp edged curve are called non-differentiable curves as per the diagram. So we know we can't draw a graph of all the equations. Okay, so better we'll learn the theory how to identify whether the graph of that equation will have smooth curve or non smooth or sharp edged curve by equations. Definition: limits, left hand derivative. First I will define left hand derivative. L f dash of x is equal to limit s tends to 0 f of x minus h minus f of x by minus h. This is called left hand derivative, and this is called right hand derivative. Or f dash of x is equal to limit s tends to 0 f of x plus h minus f of x by h. See, x minus h left hand side, x plus h is right side of x. Okay, see denominator minus h plus h, there are difference. Okay, differentiability. So definition for differentiability: a continuous function is said to be differentiable at x if L f dash of x is equal to R f dash of x. So only continuous functions can be taken for to test whether the function will have differentiation or not. Okay, the differentiability test should be done only for continuous functions. If not continuous, immediately you can say not differentiable. Okay, fine. And differentiation of f of x is denoted by f dash of x, and f dash of x is nothing but either L f dash of x or R f dash of x. Of course, only in the case of left hand derivative is equal to right hand derivative, we will say the function is differentiable. That's why we can say either L f dash of x or R f dash of x. Okay, so standard limit. Why we want standard limits now? See that your functions limits depends on limits. The L f dash of x and R f dash of x depends on limits. That's why we need standard limits. Okay, these are the standard limit formulas. Of course, to say existence of limit, you need to check the left hand limit and the right hand limit and value of the function. If all equal, we can say the function is continuous. Okay, so we'll go example. Example number 1: f of x is equal to 2x plus 3, x greater than 2, 3x minus 2, x less than or equal to 2. So this is a branching definition. So first I want to know whether the function is continuous or not. So for that reason I will find left hand limit. X tends to 2 minus f of x is equal to x tends to 2. 2 minus is indicator. It indicates that you have to choose less than 2. Less than 2 function definition is 3x minus 2. So I have to use that. And then I have to substitute x is equal to 3 2s are 6. 6 minus 2 is 4. Next, RHL. Limit x tends to 2 plus f of x. This time it is greater than 2. Greater than 2 means 2x plus 3. The function f of x follows the definition 2x plus 3. Replace it for f of x and replace for x 2. 2 2s are 4. 4 plus 3 7. So left hand derivative, left hand limit is not equal to right hand limit. So we are testing first a continuity here. Okay, f of x is continuous only if left hand limit is equal to right hand limit is equal to value of function. Here left hand limit is not equal to right hand limit. Therefore I can say f of x is not continuous at x is equal to 2, and this can imply that f of x is not differentiable at 2. So therefore this function is not differentiable. Why it is not differentiable? It is not continuous. We didn't do what the test of what L f dash of x or R f dash of x. Not required, not necessary, because differentiability should be followed only for what? Continuous function. This function first of all not a continuous function, so no need to go take it for what? Differentiability test. So here itself we can disqualify that non-differentiable. So example number 2, again I'll find what left hand limit and right hand limit. So at 0 minus means less than 0, less than 0 means the function value is what? 2x plus 3, and substitute x is equal to 0, we'll get 3. Right hand limit extends to 0, and function definition is what? Greater than 0, x plus 3, substitute x plus 3 and x equal to 0 means 3. Yes, right hand limit is what? 3, and value of function at 0 follows by the equation x plus 3, x equal to 0 na 3. So right hand value of the function also what? 3. So I can say left hand limit, right hand limit, value of function all equal. So the conclusion, the function is continuous at x equal to 0. Now we have to take it forward to test whether this function has what? Differentiation or not at x is equal to 0. So for that we have to find L f dash of 0, left hand derivative at 0, or f dash of 0, right hand derivative at 0. First I find what? L f dash of x, limit extends to 0, f of x minus h minus f of x by minus h. Okay, x value 0, because we want to test at x equal to 0. So L f dash of 0, limit is 0 minus h minus f of 0 by minus h. Next line, L f dash of 0 is equal to limit extends to 0, f of minus h minus f of 0 by minus h. And since the function f of x is equal to 2x plus 3 when x less than 0, x plus 3 when x greater than or equal to 0. Now we have to choose what? Only one definition for what? F of minus h. So it based on what? Your input minus h. We know h is a number between 0 to 1. So minus h must be a number less than 0. So we have to go over the first branch. That first branch is marked with what? Green color. So f of x is equal to 2x plus 3 we have to take. Okay. See, limit extends to 0. So minus 2h, because minus 2x plus 3, correct? So minus 2x become what? Minus 2h, because x value is what? Minus h. Minus 2h plus 3, that is for what? F of minus h, denominator minus h, minus f of 0, f of 0 is what? 3. Okay, in the next line, plus 3 minus 3 cancel, minus 2h by minus h, so plus h minus h cancel, will get what? 2. Of course this h is what? Tends to 0, now it is close to 0. Okay, near to 0 but not 0. Okay, near to 0 now it's a finite number, finite we can cancel. So that's why we get what? 2. So there is no h, so therefore the limit also what? 2. Okay, right hand limit or f dash of x is equal to limit extends to 0, f of x plus h minus f of x by h. At 0 we want to find, or f dash of 0 is equal to limit extends to 0, f of 0 plus h minus f of 0 by h, f of h minus f of 0 by h. So this time h, f of h we want to find. H is the input is what? Greater than 0, because h is the number between what? 0 to 1 at least. So x greater than 0. X greater than 0 now we have to follow function definition x plus 3 for f of x, that going to be replaced here. So limit extends to 0, x value is what? H here, because f of h. So h plus 3 minus f of 0. What is f of 0 now? 3. So plus 3 minus 3 cancel. So we'll get what? H by h. Of course h is what? Very close to 0, not equal to 0 right now. So h cancel. So we'll get what? 1. There is no h in this limit. So we can say the limit itself is what? 1. So left hand limit is not equal to left hand derivative is not equal to right hand derivative. Therefore this function is not differentiable at x is equal to 0. See, f of x is not differentiable at x is equal to 0, but it is continuous. Okay, ma'am. So we can say all continuous functions need not be differentiable. Okay, but differentiable functions are what? Continuous. Differentiable functions are what? Continuous, because a differentiability test is taken only for what? Continuous functions. So therefore I can say what? The converse need not be true. In what sense? All differentiable functions are what? A continuous, but a converse need not be true. What is converse? Differentiable continuous function are not necessarily what? Differentiable. Okay, this is an example. F of x is what? Not differentiable, but it is what? Continuous. Okay, next we'll go what? Another example. Prove that f of x is equal to modulus of x plus modulus of x minus 1 plus modulus of x minus 2 is not differentiable at x is equal to 0, x is equal to 1 and x is equal to 2. Of course, for this function we know modulus of x is continuous, modulus of x minus 1 is continuous, modulus of x minus 2 is also what? Continuous functions. So sum of three continuous functions is what? Continuous. So just directly we go what? To test differentiability. Proof. Since the function has what? A modulus, so it follows what? A branching definition. So first we remove what? Modulus. So for that I will take what? The number line like this. 0, 1, 2 is marked. Why that 0? How that 0 comes here now? Modulus of x equal to 0. Modulus of x minus 1. So x minus 1 equal to 0, x is equal to 1. X minus 2 equal to 0, x is equal to 2. So these are the critical points we want to mark it on what? The number line to remove modulus. Okay. So I have what? 4 intervals. 4 or 5? I have 5 intervals. What are that? So we'll discuss. To remove modulus, we'll follow these tabular column techniques. First, intervals we'll mark. Okay. Next, correspondent values of modulus of x, and correspondent values of modulus of x minus 1, correspondent values of x modulus of x minus 2. Then we'll find what? F of x. F of x we'll find what? As a net result. First interval minus infinity comma 0. So you see this number line minus infinity to 0 is the first interval. Then what is next interval? Yes, 0 to 1. Then what is next interval? 1 to 2. 1 to 2. And third interval 2 to infinity. So I have what? 4 intervals. In these 4 intervals we will find what? The characters of this modulus. I mean modulus of x now either plus x or minus x based on what? Plus, negative and positive. So 0 to minus infinity to 0. What is x value? Negative. So negative now modulus of x become what? Minus x. 0 to 1 positive. So plus x. 1 to 2 positive. So plus x. 2 to infinity. X value is what? A positive. So plus x. Now x minus 1. X is what? A negative number. What about x minus 1? Also negative number. So that's why we have to multiply minus with the x minus 1. So minus the x minus x minus to minus plus 1. 0 to 1. So 0 to 1 we want to know what x minus 1 is positive or negative. Take an example 0.5. If we take 0.5 minus 0.5. Minus 0.5 will give what? Minus. So in this interval it is what? Negative. So minus x plus 1. Now between 1 to 2. 1 to 2. Take a number. Any number between 1 and 2. Even 2 also you can take it. But between you take this. Good. 1.5. 1.5 minus 1. 0.5. So 0.5 is a positive number. So input is what? A positive. So we can write as such x minus 1. The next interval also 2 to infinity is positive number. So x minus 1. Now we'll go what? X minus 2. So x is negative. X minus 2 also what? Negative. So multiply by minus. Minus 2 plus 2. 0 to 1. Of course we'll go what again? 0.5. Minus x minus 2 is what? A negative. So multiply by minus. 1 to 2. 1 to 2. 1.5. 1.5 minus 2 is what? Minus 0.5. Again negative. Last 2 to infinity. 2 to infinity now we can take at least 3. 3 minus 2. 3 minus 2 is what? First number. So x minus 2. So only if the input is for a positive, we have to write as such. X minus 2 na x minus 2, x minus 1 na x minus 1, x na x. If the input, the net input is what negative, you have to replace by what negative terms of that function. That's what it's happening. This stable, the understanding of the stable column very important, not only for this chapter. If you want to do what definite integrations or applications of integrations, we want to know about what a modulus. That's very important. Next, f of x. What is f of x? F of x is what? Sum of modulus of x plus modulus of x minus 2 minus 2. So we'll add what all the numbers in the first row, g minus infinity to 0. So we'll add these all the three numbers, minus x minus x minus x. How much we'll get? Minus 3x. 1 plus 2 3. So therefore that to that corresponding row values minus infinity to 0, we'll get what? Minus 3x plus 3. So second, plus x minus x cancel, 0, 1, 1 plus 2 3. So 3 minus x or minus x plus 3. Next row we'll add 3x plus x minus x, again cancel, 2 minus 1 is what? 1. So x plus 1. The last, add the last row, 3x minus 3. That's all. This is what? F of x. Next, we'll give what? A proper branching definition. We found what? The branches. So there are what? 4 branches. Okay, we'll write in what? The standard or usual form. See, between 0 minus infinity 0 minus 3x plus 3. Okay, this is the method how we got that. Okay, now I found what? F of x with its branching definitions. Okay, now I want to test differentiability at 0, 1, 2. But I will do only one case, x is equal to 1. Other two cases you do it. Okay, so test the differentiability of f of x at x is equal to 1. Let us find L f dash of 1 and R f dash of 1. L f dash of x means left hand derivative, which is equal to limit x tends to 0 f of x minus h minus f of x by minus h. Replace x is equal to 1. So that we'll get 1 minus h. Okay. H is a number between 0 to 1, correct? So 1 minus h become what? Number between 0 to 1. For example, 0.5. H is what? 0.5 now. 1 minus 0.5 is what? Again 0.5. So it's the number between 0 to 1 in general. Okay. So input 1 minus h is a number between 0 to 1. 0 to 1 now, minus x plus 3. We have to take it for what? F of x. And f of 1. F of 1, where it is included? 1. I think second row. So minus x plus 3, it is included. So x value is what? 1. So minus x means minus 1 plus 3 is equal to 2. So f of 1 is equal to 2. And f of 1 minus h comes from what? Minus x plus 3. So we'll continue the calculation. See, minus x value is what? 1 minus h plus 3. Okay, wow. Minus f of 1. What is f of 1? 2. And denominator minus h. We'll simplify this equation. 3 minus 1 is what? 2 minus 2 minus plus h. Okay, that is what? The bracket, the set bracket. Next, minus 2 plus 2 minus 2 cancel. Then next step. So h by minus h. H is what? Non-zero number right now because h tends to 0. So h cancel. We get what? Minus 1. It's the left hand derivative. Correct? At 1. Next, right hand derivative at 1. R f dash of x is equal to limit x tends to 0 f of x plus h minus f of x by h is the definition. X value is what? 1. And h is a number between 0 to 1. And what about what? 1 plus h. 1 plus h automatically become what? 1 to 2. H is a number between 0 to 1. Now 1 plus h. Just add 1 with what? All the three. So 1 to 2. Therefore f of x is equal to x plus 1. If x is a number between 1 and 2, input is what? Between 1 and 2. 1 and 2 will go what? X plus 1. F of x must be what? X plus 1. And f of 1 same reason. So it is equal to 2. So we'll find what? Right hand limit. So f of x is what? X plus 1. Okay, but I want what? F of 1 plus h. So x must be replaced by what? 1 plus h plus 1. This is what f of minus 2 by h plus 2 minus 2 I think cancel. Okay, that we'll do it next step. H by h is non-zero number, cancel 1. So right hand derivative is equal to 1. Okay. Differentiability means smooth curve, non-differentiable means sharp edged. Okay. So L f dash of 1 is not equal to R f dash of 1. Therefore, f of x is not differentiable at x is equal to 1. But it is what? Continuous at 1. That's all. Thank you. All the best.